In this lesson, we will discuss basic concepts in mining frequent patterns. We will go over basic concepts of pattern discovery, why it's important, and define key terminologies like transactional databases, k-itemsets, support, and confidence. No matter what the application is, pattern discovery plays an important role in decision making. Consider big retail like Walmart. They sell thousands of items every day and they need to optimize their operations. Similarly, stock trading has a lot to do with analyzing the market's past behavior to predict which stocks to buy. Healthcare is another big example, going from diagnosis to healthcare plans, looking for new medications. So it has a lot to do with analyzing very large data sets and trying to find these insights. A pattern is a recurring set of items, subsequences, substructures within the data. It doesn't always refer to a single entity. It can represent series of purchases, sequence of events, or even structural relationships within complex dataset. But most importantly, patterns represent intrinsic and important properties of the dataset. Here are a few examples. Frequent item set, like the individual items one might buy from a grocery store. Frequent sequences are patterns that follow a sequence. For example, after buying a computer, one might want to buy accessories, connector, adapter, maybe a drawing pad. Also, events can be sequenced. Let's say someone experienced a flat tire, then they have to buy the tire, install it, do safety checks. So it's not just physical things, it could be events. For frequent structures, we can think about graphs. Let's say in chemistry or pharmacology, they need to develop new compounds, then they have to search through all of these different graphs to find the one that matches their requirements. To summarize as a big picture, the problem formulation of pattern discovery is to find interesting patterns with intrinsic properties from the dataset. So a frequent pattern like buying banana and bread is not that interesting. But if we look at buying beer and diapers together, there seems to be something going on and we need to further explore. Why is pattern discovery important? Because it allows uncovering associations and correlations within the data. But these relationships are not necessarily causal, but they can support causality analysis. Also, pattern discovery isn't limited to text or substructures or item sets. It can be applied to virtually any data type. Also, they can be very useful in pattern-based classification and clustering. Broad applications include market basket analysis, marketing, sales, web log analysis, biology, among others. Many rich data types and diverse data types like spatiotemporal, multimedia, time series, examples, finding patterns in weather or traffic. Also, data is not always static. It can come from streams like sensors, live cameras, or continuous online activity. Now, let's set the stage for the algorithms that will perform frequent pattern mining. We will start with a super simplified example, a small transactional database. This database contains a set of transactions. Each transaction consists of a set of items. Some of these items will co-occur. So the goal is to find patterns and associations. We will call the transactional database TDB. For example, one transactional database contains a transaction like beer, nuts, diaper, beer, coffee, diaper, and so on. Next, we want to track how frequently items like beer, nuts, or diaper appear in transactions. In other words, we need to define a measure that captures the frequency of item sets. An item set is a set of one or more items, and a transaction might contain just a single item or as many as 100, but it's still considered an item set. To make the problem more manageable, we can narrow our focus to a specific number of transactions, let's say 5, 10, 20, which leads us to the definition of k-item set, which is an item set that consists of k items. In this example, we have beer, nuts, diaper, so this is a 3-item set. Now we want to define a measure to determine whether an item or item set occur frequently enough to be worth our attention. Absolute support is a simple way to capture this. It counts how many transactions contain a given item set. For example, the support of beer is 3. It means that beer appeared in 3 transactions. Now, this measure applies to both single item and item sets. For instance, the support of beer and diaper together is 3, beer and eggs 1, support of diaper is 4. But sometimes it's more useful to express support as a proportion of the dataset. But sometimes it's more useful to express support as a proportion of the dataset because absolute counts alone can be misleading. For example, 3 occurrences might be significant in a dataset of 5 transactions, but not so much in a dataset of 100 transactions. So relative support addresses this issue by dividing the absolute support over the total number of transactions in the dataset. Here are a few examples. The relative support of beer is 3 over 5, which is 60%. Support of diapers, 80%. And beer and eggs together is 20%. What makes an item set frequent? We need a threshold to define frequency. An item set X is frequent if support of X is no less than the minimum support threshold. Let's set up the minimum support threshold to 50. So beer is frequent, nuts, diaper, eggs, but milk is not frequent because it appeared in 2 transactions. So it's 40%. For 2 item sets, we have beer and diaper together frequent, and we don't have a frequent 3 item set in this example. Now we are going to talk about 2 concepts, item sets and association. An item set is simply a collection of items like beer, diaper, coffee, whereas an association captures a relationship between items. For example, if someone buys diapers, they might also buy beer. This is expressed as an association rule. It's important to note that this is not a causal relationship, it's just an association rule. We like to think of association rules in terms of a Venn diagram. One circle represents beer, the other represents diapers. The association occurs when these circles overlap, when someone buys both beer and diapers. I want you to pay attention to the notation, which is a little bit confusing. So in the frequent pattern mining literature, you'll often see the union symbol to represent the overlap between the 2 item sets. So the union means the set contains both X and Y. It's not X or Y as in the discrete dataset. To measure the strength of an association rule, we calculate support and confidence. Confidence measures how often an item Y appears in transactions that contain item X. In other words, it's the conditional probability that a transaction containing X also contains Y. It's computed as the support of X and Y divided by the support of X. So to find the confidence, we are going to find the support of diaper and beer, which is 3, divided over the support of diaper, which is 4. And this is how we ended up with the 0.75. To wrap up, pattern analysis is interested in rules that dominate the database, and computing support and confidence ensure that the popularity and the correlation of these items X and Y. In summary, we discussed basic concepts in frequent pattern mining. We looked at the k-frequent item sets and defined measures like support and confidence.